Welcome back to another episode of the Reliability Matters podcast. This is episode number 133. We are all aware of the damage electrostatic discharge can wreak on components and electronic products. We mitigate ESD damage through various forms of monitoring. We wear wrist and heel straps, we stand on ESD-safe flooring, we utilize ESD workstations, and much more. We even have ESD testing locations that will test a human standing on a specialized testing station. But what happens the moment that person steps off the tester? My guests today are Dr. Daan Stevenson and Dr. Jonathan Tapson of IONA Tech, a manufacturer of a novel wearable ESD monitoring device that provides consistent and real-time ESD monitoring. Now, normally I don't talk about specific products on this show. We usually limit our conversations to best practices. This is a little bit of an exception to my normal rule. From time to time, a product is introduced that is so novel, it's worthy of a conversation, and that's the case here. Dr. Daan Stevenson is the Chief Executive Officer of IONA Tech. Daan has a background in mechanical engineering and aerospace engineering. During his doctoral research, he studied the high-voltage charging of spacecraft, which are electrical capacitors in the same way that the human body is. While working to design an automated ground station for UAVs, he frequently damaged electrical components from electrostatic shocks. This motivated the creation of IONA Tech, with the goal of advancing technology in ESD mitigation. My other guest is Dr. Jonathan Tapson, Chief Technology Officer for IONA Tech. Jonathan was professor of electrical engineering at Western Sydney University before moving to Telluride, Colorado in 2016. He spent his early career conducting sensor and instrumentation research with a strong industrial focus. During this time, he spun out 3 companies from his research, all of which are successful today. His specialties include low-noise circuits and systems design, mechatronics design, and the integration of machine learning into real-time systems. So when I come back in just a moment, it will be my complete pleasure to introduce Dr. Daan Stevenson and Dr. Jonathan Tapson to the show. I'll see you in a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back, and a special welcome to Daan Stevenson and Jonathan Tapson for being on the show. Thank you so much for being here, fellas.
Hey, Mike. Thanks for having us.
Yeah, thank you very much.
Well, my pleasure. It's not often I get to talk to someone who has created what, at least from my layman standpoint, what appears to be a pretty revolutionary product. I would even go beyond evolution. There's 2 forms of progress in our industry. 95 or maybe even 99% of it is evolution, because pretty much every electronic product we have today, most of the electronic products we have today are simply evolutions of larger, slower, more expensive versions of what we had 30, 40 years ago, right? And it's not too often something quite revolutionary comes along. And I'm not sure if the tech is revolutionary. It's certainly a revolutionary application of technology. And to the best of my knowledge, your product, there doesn't seem to be some also-rans in this world and what you have done. You appear to be, from what I can see, the first. You can correct me if I'm wrong. So I've spoken to many entrepreneurs over the years that I've been producing this podcast. And what I've learned is there are basically 3 motivations for introducing a product. The first motivation is the realization that there's enough space for another similar product. And, I kind of call those also-rans or Me Too type products. Then there is another reason that entrepreneurs will start a business, and that is there's an existing product out there that they think they can make better. So that is, kind of a better mousetrap type of product. And then the third, and a good example of that would be going back to the Steve Jobs days at Apple. Apple didn't invent the mouse. Xerox PARC had the mouse. They inspired Steve because we could use that in our stuff. the fonts that they brought out, proportionally spaced fonts, that was a result of calligraphy courses he took in college, after he kind of officially dropped out of his major. So none of those were invented by him, but they were certainly exploited, and I say that in a good way, by him. So that's an improvement motivation to start a product. And then the third reason is someone has thought of a revolutionary product, something that is not currently out on the market. And which of those, if they can fall into one of those three categories, which of those applies to your company and your product?
Yeah, well, I think it's definitely a very novel product, and that there's nothing out there in the market that does what our product, the Static Band, does. So it's a wearable monitor of human body charge and voltage. It's kind of an extension of the existing charge plate monitor voltage devices, but it comes with a lot of benefits, just the ability to move around freely without any tethers and requiring to find an outlet and truck the equipment around on a cart while you're moving through a facility. Really kind of puts us in a category of its own. I'd say, yeah, we kind of came and looked at the ESD problem from an outsider's point of view. As electrical engineers, we kind of had experience and personal pain points with the existing products that were out there, and but not ingrained kind of in the industry. And so we were able to look and see what does this really need? And we identified that kind of the visibility into the ESD problem was completely lacking. ESD, of course, as you introduced, electrostatic discharge, which can easily damage electronics products when handling it at voltages much lower than where you'd actually feel an electrostatic shock. And yeah, we designed and built a product and brought it to market that really gives you insights into when your body is charged up in a completely novel way, and in a way that's easy to use as well, rather than kind of an ESD auditor or an expert utilizing this very specialized equipment. Anybody in the facility can use our product to see what's happening in their environment with regards to ESD.
Yeah. I want to say that I think the key and revolutionary thing in our product was an insight that Daan had 4 or 5 years ago, which is that you can measure the voltage of an object without attaching any wires to that object, and you can measure it from on the object, which in our case obviously is a human being. And that was just one of those things that intuitively you think you can't do. And the way that we've done it now seems simple, but it came from Daan's kind of 5 years of PhD insight into electrostatics that actually, he had that intuition. And I'm not an idiot, but it took him 18 months to convince me that it was feasible just from a physics point of view. So that was the key there. That was the revolutionary insight. And
I think what makes this product, at least from my perspective, quite attractive is, the term wireless. You're able to measure something without actually touching it. And we live in a very wireless mentality right now. When I remember the first VCR my wife and I purchased, I think it was $1,500, it may have been $2,000, way back in the day. And it had a remote control connected by a wire. It had like a 30-foot tether on this remote control. And all it did was, pause and play. That was about it, and rewind and forward. But we were the envy of all of our friends, because the generation of VCRs before that were like a tape deck you had to go up to the machine and push down the play button, like an old cassette player, for those who remember what cassette players were. So the wireless aspect kind of just fits in our modern technological psyche. We expect everything to be wireless. Even charging phones now is all done wirelessly. So that kind of fits. Did you guys invent this product? At first, was the motivation to fill a need internally, and then you kind of realized you were onto something and thought maybe there could be a greater market for it? Or what was the motivation to say? I know I found a lot of solace, Daan, when I read the part of your bio that you had blown up a bunch of parts. It was like, hey, if he can do it, we're okay, because I've done the same thing. Particularly if you're blowing up parts and you have a background in ESD, that's pretty cool. It's like watching professional golfers have a bad swing. It's like some solace there, right? But was the motivation at first, at least, internal, and then it became an external motivation?
Yeah, I mean, you alluded to it a little bit in your introduction, but I was kind of a founding member of or early engineering member of a startup making ground stations for drones, and we built these large installations for UAVs to come and autonomously land, swap the battery, and be on its way again. And I set up a shop in Denver, Colorado, dry climate, and I would reach in and work on the circuits of this pretty intricate machine and get a big shock, and things were not working. And as you might know, luckily it was a prototype and not quite on the production line yet, but it's hard enough to get a prototype working as it is. And then to throw in this issue of ESD just makes everything more frustrating and difficult to get reliable, to get working reliably. And then I had that background in electrostatics from spacecraft, and I started looking long and hard into how can we tackle this problem in a better way. And when John and I met here in Telluride, Colorado, and had similar kind of academic and engineering interests, it was kind of a lucky match made in heaven. And then we received an NSF grant, an SBIR grant to start working on this, and that allowed us to kind of jump in with both feet and really make this happen.
So living and working in Telluride, does that mean that you only produce product during the summer, and in the wintertime you're on the slopes?
We found less time for skiing and the outdoor activities the last couple of years, but it's a nice place to be working out of.
We do have what's called locally a 6-inch rule, which means that if there are 6 inches of fresh powder, it's acceptable not to get to work before lunchtime.
There you go. Yeah. There are 24 hours in a day, by the way, not just 8. So yeah, you can time shift a little bit. So Daan, we talked a little bit about your professional background. Jonathan, where did you come from, and what was your background?
So I had been a professional academic for many years, and I rose through the ranks. I was a professor, and then an academic dean, and then the director of a large research institute. And I got to a point in academia where I could either keep doing the same thing again, or I could move up and become a bureaucrat, which is the kind of final resting place of academics. And I had done 3 startups in my early career, but I hadn't actually accompanied them all the way to success. And it had always kind of niggled me. I thought, what's it like to really commit and do one of these things completely from the beginning to the end and go through the whole process. So I had that sort of in the back of my mind. And then when I met Daan, and it was such an interesting idea, and we got initial support from the NSF to make it a reality. So it just seemed like a great opportunity.
You've turned the old phrase, those that can do, those that can't teach, totally upside down, because you went from an educational world to a real practical world. Was that quite a shock for you?
Not really. I was always trying to maintain relevance as an academic. So always trying to keep one foot in reality. And because I was acutely aware of that old saying, and I believe it's 99% of the time it's true. But nonetheless, it's hard to maintain currency. I think I had to go back and learn basic skills that I've learned and forgotten 2 or 3 times over in the course of my career. And of course, the technology changes. And that's been fun, getting current again in things like PCB manufacture, which is just so much easier than it used to be, has been a whole lot of fun. But the fundamentals don't change. So that's been good.
Yeah. All right, let's, before we dive into the technology and how it works and how it was created and what the challenges were and its benefits and all that kind of stuff, let's just kind of, I'm going to play a video, and perhaps you can kind of narrate over it and allow my audience to see what this product is. Now, for those of my audience who are listening to this through their headphones on the treadmill or in the car, you might get a little bit of FOMO because you're not seeing this. So for those of my listening audience that would like to know what we are talking about, I would encourage you, at least for this episode, to go on the Reliability Matters YouTube channel, look up episode number 133. That's this one, and you can see what we are talking about. And I will put a link in the show notes if you are not able to go on YouTube and see what we're talking about. Use your imagination. And I will put in the show notes links to the IONA Tech website so you can see some of the videos and illustrations that we're showing here. So whoever wants to jump in, here's the video running that shows the product in use. What are we seeing here?
Okay, so it's a wearable device, and you wear it high up on your shoulder to keep it out of the way. It contains an electric field sensor, which is the gold object that you see. And we found that high on the shoulder is the best combination of ergonomics and also getting a good electric field measurement. For practical reasons, you don't want to have it on your hand or your wrist.
And I'm seeing the person wearing this over an ESD smock. I'm assuming that you're not going to put it over your, North Face jacket or something, right? This has to be mounted on something conductive.
Yeah, that's a great insight. It needs to accurately represent the voltage of your skin, if you like. So an ESD shirt that makes electrical contact with your skin is good. Anything with a little bit of conductivity, or even something that doesn't generate charge. So as you say, a fleece from North Face would generate a bunch of charge. We all know, we've all had that experience. That wouldn't be practical. But a cotton shirt or a proper ESD garment is great.
Okay, I'll keep the video going. Right now we're showing someone wearing it. They're now turning it on.
Yeah, so it turns on and off with a single button that can also mute it. And as you see now, Daan is walking around. And if you can pause there. So what happened there was he walked around on a non-ESD floor, and he generated some charge, got himself up to or down to minus 400 volts or so. And then he touched a grounded point. And what we see, and that's what's actually being shown, is the representation of that device on an app, on an iPhone app, smartphone app. And you can see on the graph that his voltage, when he touched ground, his voltage shot up from minus 400 to 0. But at the same time, you can see a red dot, and then that represents an ESD event. So that is the device actually recording that an ESD discharge happened. And if he had been touching a circuit at that moment, that would have been the record that he'd probably damaged that circuit, or certainly that circuit is now in doubt. Depending on the magnitude of the discharge, you might want to retest that circuit.
And where that red dot appears in the graph, does that generate an audible alarm of some sort? So Daan knows what he's done?
Yes.
Okay, let's keep the video going here.
Okay, and this is a representation of the configuration through the app. You can set the voltage level because different environments require a different level of voltage awareness, if you like. So in a general electronics environment, 1,000 volt thresholds might be okay. But if you're putting a prototype imager onto a satellite, then you'd want to be less than 100 volts. If you were integrating the James Webb Space Telescope, you'd definitely want to be down way below 100 volts because of the sensitivity of those kind of electronics. So you can set that level. You can also set the loudness of the alarms, whether they're audible or not, and whether you in fact hear them or not.
Interesting. All right, moving on.
Okay, this shows a little device we call the zero disk. And this shows how you zero the device to get an extremely accurate zero level. It drifts about maybe 10 volts through the course of a day. And we find that you don't really need to zero them in regular use. But if you are in a particular situation where you really want to get perfect accuracy out of the static band, you cover it with this zero disk, which has a little prong that pushes a hidden button, and that zeros the device, and it's then good to go with a known reference level.
Is that considered calibration, or is there another procedure for calibration?
It's calibrated when we manufacture it, and we can recalibrate it. Folks in the ESD industry like to recalibrate stuff once a year, and so we will happily recalibrate this once a year.
Okay.
But it's also understood in the industry that sometimes the zero drifts and you need to reset that. Okay, what you see there is a downloaded set of data from the app. So if you want to record some length of time, anything from a few seconds to many hours, you can record your voltage for that length of time, and you can download it so that you can graph it. You get a CSV file, and you can drop that into any spreadsheet program and graph it.
Excellent. Now this looks interesting. This is obviously a view of a laptop screen. This is a computer version of the handheld app, right?
Yeah. So you can record from several of these devices using a central hub, which can also just be a PC. And that gets the data from multiple devices into a database. And we can then serve the information from that database over the web in this kind of dashboard view. So you can record from multiple people or objects inside a plant and get that record over many hours or days or months or years, and try and understand the ESD prevalence in your factory using that view. And you can also get humidity and temperature from our hub, which are often key variables in understanding what's going on from an ESD point of view. And you have a permanent record of all the alarms which were generated. So the idea here is you can use this as an analytical tool from a reliability point of view to figure out where are the hotspots in my factory, where are the problems happening.
Interesting. So one of the obvious questions that comes to mind is, what took so long for something like this to come out? We've been dealing with tethered devices and point testing, testing a floor, testing a workbench, testing heel straps, testing wrist straps. But anything away from those test methods is uncharted territory, or at least unmonitored territory. What took so long, guys?
I think a part of the kind of innovative leap here is this concept of measuring from on body, right? A conventional field meter is calibrated to be kind of pointed at an object about an inch away. It's measuring an electric field, but it's converting that to the voltage of the object that you're pointing at. And so kind of maybe because I've been thinking in terms of satellites charging up to very high voltages in space, and how can you measure this from the satellite, I kind of had this concept of, hey, we can actually put that field meter on the body and just kind of some insights into electrostatics say that field measurement on the surface is actually equal to linearly related to the charge at that surface, right? And then it's a pretty simple step to extrapolate that to total charge on your body and then voltage with the capacitance relationship. So I think part of that is what made it difficult to create a product like this, but also just miniaturizing the electric field mill so that it could be an on-body device and really accurately measure the field. I mean, that took a lot of engineering, modern kind of electronics components. And then honestly, we're using kind of cutting edge microprocessors that can run the algorithms necessary to run the field mill and the algorithms to detect these ESD events. Some insights into the material science of all the components kind of around the field mill that were very important. And so, yeah, I think a combination of good engineering and kind of this mental leap of realizing that you can actually measure without any tethers kind of the charge on a body in situ, as we like to say, kind of from the site.
So things that's in Bluetooth technology that's super easy to integrate so that you can get the wireless reporting going easily, which was not impossible 10 or 15 years ago, but it took a research team to get it going, and now you can do it very much more easily.
So each person wearing this would have the app on their own phone, or do your customers hand out a dedicated phone for that purpose, or?
Yeah, so the first of all, the alarms work whether you've got any backend connected or not. So even without a phone or anything connected, you can react to the alarms generated when you're above a threshold voltage and use this to kind of manage your ESD in your environment. The mobile phone was built for kind of to connect to a single device, and it's more kind of an application of, hey, I'm walking through a facility trying to see evaluate the floor to make sure that my body voltage stays low kind of in every corner. And that's kind of the mobile app, and it's made to be really intuitive, easy for anybody in the factory to pick up a device and use and kind of look at the ESD conditions, I suppose. The dashboard view that you saw, that requires kind of a hub, some extra hardware, and some repeaters so that the devices are always in range. And that gives the ability to have multiple devices kind of streaming the data and recording all those ESD events. And what's really cool there is a quality control manager or ESD manager can get notifications, whether via email or text message, that, hey, there's a lot of ESD events going on in this corner of the facility. You might want to have a look. And that really enables this kind of stop the line quality control that I think exists in every other corner of manufacturing, but just hasn't been possible before managing ESD concerns.
So before I ask you this next question about what are the advantages of real-time wearable ESD monitoring compared to traditional fixed, let me give you an example of an old traditional fixed. I entered into this industry in 1985, and I think in 85 or 86, I went to tour a contract manufacturer that was doing work in ESD. I'm not sure when ESD mitigation or ESD, the knowledge, the awareness, the general awareness of ESD damage first came on the scene, but it seems like we were kind of in that era. And this company had hastily set up an ESD program. And I'm not kidding when I tell you this. They had rows of cables near the ceiling, maybe 10 feet in the air, stretched very tight. And they had metal rings hanging from the cables. The metal rings were about 5 inches in diameter. They were heavy enough so that they applied pressure against the top of the cable. Then they had wires with wrist straps attached to each of those rings. And they set up the cables to be kind of north, south, east, west. And if you were walking from south to north, you were dragging along, literally pulling along this metal ring against the cable, dragging it along the cable. The problem was when you had to change directions, you had to swap wrist straps to get another ring, which was going, east to west. And it reminded me of the movie Christmas Carol, Scrooge, when Jacob Marley, covered in chains, came to visit Scrooge. And the sound of the metal chains that were made in that movie was very similar to watching all these technicians walking up and down their factory floor, dragging these metal rings against metal cables. So clearly, this is an advantage to that. But beyond the super obvious, which is wireless, what in your experience has been demonstrated to be some of the advantages, maybe known ahead of time and maybe realized after the fact, of a wireless technology for ESD mitigation?
Right. So you hit the nail on the head with the fact that not being connected to wires is an awesome advantage, and it's a benefit in a lot of situations, but actually it's essential in others. And for example, as development engineers, you don't realize that engineers never sit still for any length of time. They're always getting up and moving around. You're going to look up a data sheet or get a component or something like that. So to be tethered is practically impossible. And there's a joke in the ESD industry that the laws of physics don't apply to engineers because engineers just flat out refuse to wear tethers. So, and not just for engineers, but I use that as an example. Just to be able to not worry about a wrist tether is a tremendously valuable thing. The second thing that we're finding that we perhaps didn't really expect early on is the visibility it gives you into what causes ESD and how you interact with electrostatics is just amazing. You get up out of a chair, you don't even have to get up out of a chair. You lean forward from the back of the chair, and your separation of your garment from the plastic back of the chair, you're suddenly at 1600 volts, which I would never have believed if I hadn't been wearing a device measuring my body voltage to tell me that. So the extent to which you build a much better intuition about where electrostatic danger is in your environment, in your engineering environment, is tremendous. And then this idea that you can detect bad equipment. The very first place when we went on site to do our very first beta test, we put this on a guy who told us that his facility had a very high ESD standard, and he genuinely believed that. And he came back 10 months later and he said, I just realized that my own personal wrist tether has been broken internally for I don't know how long. It looked fine. And your device told me that my voltage was fluctuating all over the place when I was tethered. So that kind of intuition. And then it just becomes this fantastic mobile probe, if you like, of a factory floor. We were wandering around a really impressive factory down in Mexico that had superb state-of-the-art static controls. And I thought it was going to be a complete waste of our time because I thought our unit would flatline the whole time. And I wandered past a shelf of pick-and-place components on rotary carousels, and my device went off because it detected charge. And we kind of moved a little closer to this shelf, and it turned out some of these carousels were made of a non-compliant plastic that was holding charge that it shouldn't have. I mean, they were just from a supplier who hadn't supplied the right stuff. But you just don't have that visibility any other way. So right. Yeah, it's been good from that point of view.
I want to jump in real quick, and John mentioned it's great to kind of get away from tethers, and that is absolutely a personal pain point. You know, being literally leashed to a desk is about the worst kind of user experience ever when you're needing to control your charge buildup. I just want to make it clear to all your listeners that so our device does not actually mitigate static, right? It's just a monitor that lets you know when you are charged. So in order to make sure that there's no ESD events happening, no body voltage above a threshold, we're still reliant on kind of the other, mitigation processes in a facility, such as a wrist strap. But in the case of mobile, people who require mobility that rely on, ESD flooring with footwear, ionizers, that kind of thing, the static band can really verify that all those other components are working correctly. And if you have kind of the alarms turned on and you react to those alarms, we've found that you can actually work in an ESD-safe manner as long as there's kind of a ground point nearby, right? We often solder on these dissipative mats. And when you go to sit down at a workstation, you generate a lot of high voltage. The alarm will sound, at that point, don't handle the electronics. But if you then touch the dissipative work surface, you can bring your body voltage back down. And then as long as kind of you're working and there's no alarms going on, you know that you're ESD compliant. So that's a way that we can actually utilize a static band to work without constantly being leashed or tethered to a ground point.
Yeah, I'm glad you made that distinction because I referred to it as static mitigation. And in a technical sense, you're absolutely right. It's not a mitigation thing. However, the awareness of when you're generating a charge, the awareness of when an alarm goes off will, I would think, start resulting in behavioral changes. And those behavioral changes will reduce static events. So in an indirect way, maybe not technically speaking, but in a super indirect way, it does mitigate if, because wearing a wrist strap with a broken connector, does not mitigate anything, right? And there's no awareness. So wearing a broken wrist strap and having some other type of device, which doesn't rely on a tether, a wire, will result in kind of a de facto wrist strap tester or a de facto ESD floor tester or a de facto heel strap sensor. It's not designed for all those specific applications, but it will alarm if those conditions break down and stop working. So
yeah, sometimes we see this as kind of a constant monitor, the one that you would plug a wrist strap into to make sure that you're making good contact to your skin, but for the mobile employee, right? So you've got a constant monitor on all your mobile ESD mitigation techniques.
Yeah, I see it as a really good filler for, a factory floor that has a really good ESD strategy, has all these points of test. Everything's tested here and then there, but not in between. And I can't tell you how many times I've seen people walking around in a conductive tray, a static tray, but they're just walking around and they go into maybe the shipping and receiving department or some other part of the factory floor that is not as ESD sensitive, or it's not, they don't have the devices in place. And And this is not predicated on one moment in time when you tested good, right? It's all the other times when you're not being tested that really, it's the weakest link, right? It patches up that weakest link. What were some of the challenges that you faced when designing this type of product?
Yeah, so we spent a lot of time getting this electric field mill to be accurate and free of drift. I mean, that was a real kind of technological hurdle. And we achieved it with kind of persistence and good data collection. Honestly, we've been a data-driven company from the very beginning, and that kind of shows in the product. And just collecting kind of the information we needed to make iterative improvements on the sensor design have paid off because of how accurate the device is now, where we can actually measure the body voltage to within 10 volts, which is quite impressive. I'd say another challenge was making sure that the UI, the user interface, was intuitive. I mean, kind of anybody who picks this device up, we had kind of an electrical engineering YouTube influencer review this product, and he did a 20-30 minute review, and he didn't even read the manual of the device. Literally kind of picked it up out of the box and installed the app and started using it and was able to test it. So I think that's kind of a testament to how well we achieved that. And then the large challenge has been kind of acceptance in this industry, which is conservative, I think, by nature and justifiably so, because it's so hard to see ESD and charge generation. And so, you've seen kind of these hokey wireless wrist strap, supposedly mitigation devices come on the market. And because it's really hard to tell whether that's doing anything for you or not, they kind of gain acceptance. And then there was a large pushback, which luckily kind of made it clear to everyone that this was not a viable ESD mitigation practice. But interestingly enough, with our device, we provide that visibility to see, hey, how are things working? And I think, ultimately, we've made a product that's kind of undeniable and applicable in so many corners of the industry that it's only a matter of time.
Yeah, I was gonna ask you this question 3 pages from now, but you brought it up. It's a good segue. There are certain parts of our industry, the electronic assembly world, that are super conservative. And I look at military customers, our military customers, defense, and to a certain extent medical, and all that are just notoriously inflexible with new technologies. I always joke that on the way to work every morning, they're listening to John Cougar Mellencamp on their 8-track tape in their 1975 Pinto on the way to work. Well, they create the world's greatest technologies, but they're very conservative. They don't like to change. Back in the day, when the weapons standard, weapon spec 6536, which eventually morphed into MIL standard 2000A, they were all kind of derived out of China Lake, California, and now IPC is kind of taken over the standards world. But back in those days, there was a phrase in the standards that basically said, to paraphrase loosely, do it this way. And if you want to do it another way, it's subject to review and disapproval. That part was verbatim, subject to review and disapproval. And who wanted to stick their neck out, right, when they're building such, high reliability, failure's not an option type product. So certain industries like the military are very slow to adapt and adopt new technologies. Are you facing some of that, or are the results just so convincing that people become believers right away, or is there still a level of that's not the way we do things?
Well, definitely some of that, particularly in terms of the standards, because standards, I mean, for example, a lot of standards won't let you use a patented device, which these are, because they don't want the standard to be locked into
commercial.
For example. But at the same time, I think there is, within all of those industries are individual people who think out of the box, even in the military. I've always found the military this bizarre combination of the kind of dyed-in-the-wool conservatism that you've described, and then the most wacky out-of-the-box willingness to try stuff. And I think what we'll find is that they will have some compelling applications. And we already had someone from a branch of the military saying, I have to hang a technician in the tail cone of a missile from a crane and keep them grounded, and it's driving me crazy, and it's impossible, and it has its own occupational safety issues. And so maybe your device is the answer for that. And I think we'll see these situations where they use it because nothing else will work. And then they say, hey, no, this thing works. Well, why don't we use it a little more widely? They'll start using it out of compulsion, and then they'll start using it out of convenience in due course. But what we're absolutely certain of is, for the longest time, they will only use it in parallel with existing controls, simply because that belt and braces approach is safe. I mean, you can't argue with it.
Right, and they're not going to take something out of a standard that they have. They're going to just add to it maybe, but not at the expense of something else. Which brings me to this question. Do you see your product replacing current technologies or working in concert with current technologies?
It's a combination of both, right? I think at the start, it's verification of other products, mitigation products for ESD. Really, we see this as a very cheap insurance policy that the 6 figures, 7 figures of ESD equipment built into a larger facility is working as it should, right? In a lot of cases, there is no kind of verification, day in, day out, constant verification of those products. So that's the value that the static band adds, especially when you have it in this enterprise installation that we have available with the hub and the dashboard. But as you said, I think as we were discussing in an R&D environment, you can absolutely use this kind of as a standalone product. And we have some customers that have small electronic shops that are applying it in this way. Just to go back to your last question as well, I mean, ultimately the proof is in the pudding, right? It's really hard to refute this when you're holding a tether of a charge plate monitor, voltage device, and a static band on your arm, and you see the curves track perfectly. And then you touch a ground point and you hear beeps from the alarm going off. I mean, the proof really is in the pudding with this device. And the second kind of our customers get it in their hands, they see the value of what they have here. For us, it's still exciting. I mean, we've gotten over the joy of reaching for a ground point and hearing the beep, beep, beep go off. But every once in a while, I'm wearing a static band and I walk past maybe an open conductor or a wire that's hanging and brush a light past it. And then I hear the discharge alarm go off. What was that? And that's when it's really cool that this is really identifying, the invisible, the ESD events you don't feel, you don't realize they happen, and they cause latent damage to electronics that might pop up, years later in its life under operation. And just having that visibility is really key.
So in addition to simply sounding an alarm, you mentioned that if someone's not using the app, it can just act as an alarm. It'll just sound an audible alarm when a static event is taking place. But assuming that that the user takes advantage of all the different metrics that it's measuring and monitoring, what are some of the data sets that are captured in addition to just an alarm went off?
The main data set, yeah, the fundamental data sets are the body voltage over long periods of time. And then the over and above that, we'll add on that are the alarms that are generated. So actual events of exceeding voltage and events of discharging charge into handled objects. But what you can construct from that becomes really interesting because it gives you traceability. I can then, I can move from saying, okay, I know what the worker's voltages were, to being able to show the quality of an object. And so I might have a satellite. I might be a subcontractor handling satellite, and I've received a half-manufactured satellite, and I'm going to hand over a fully manufactured satellite to an end user. I can show the full traceability, the full ESD history of that satellite in terms of the people who are around it and handled it, and show to the person receiving it that nobody touched that satellite who was over 10 volts in voltage at any time. Got the full record, and that kind of auditability, I think, is going to become tremendously rich over a period of time. I think people will see value in that.
Yeah, up to now, the proof that a static event did or did not take place is the product is still working, which doesn't mean it didn't take place, I suppose. But certainly, if it's not working, when we can assume something did take place. That makes a lot of sense. Let's spend a few minutes and kind of help my my listeners and my viewers understand how this product works. So I'm going to bring up this slide right here. This is entitled, "How do we do it?" which is a really good question. So how'd you do this?
Yeah, so this slide shows that basic electrostatics kind of first principle electrostatic concept that on the surface of a conductor, the electric field is perpendicular to that conductor, and it is linearly related with the permittivity of free space to the surface charge density. So that's that last equation there. E field measured on the surface of a conductor is sigma over epsilon naught, where sigma is kind of coulombs per meter squared type charge density, right? So that's a concept that, I think is not familiar to many people, but is absolutely the foundation of why this works. When you measure the electric field on the surface of a conductor, you have a measure of the surface charge density, the local charge density there.
Interesting.
And then I think the next slide shows how we then extrapolate that. You can pull that up. Yeah, so you've got the armband, the static band kind of on the upper arm. We have there a measure of E field and measure of charge. The total charge then is kind of the extrapolation or integral of that surface charge density over your whole body. And then also the total charge is related to total voltage by the capacitance, right? And so we found empirically by comparing it to existing kind of tethered body voltage measurements that actually correlates incredibly well for a wide range of body voltages. And for that extra kind of 10% accuracy, we can correct for kind of height and weight if we needed to. And so, yeah, essentially we're measuring local charge, extrapolating the total charge, and then converting that to voltage. And there's another slide there that shows that, hey, this really only works in free space. When you stand kind of next to either a charged object or just kind of a conducting wall, that often induces kind of a charge on your body towards that external charge. And since we're measuring E field and charge, the static band actually kind of picks those induced charges up as well in the measurement. So at that point, our measurement and your actual body voltage diverge slightly. But ultimately, it's charge that creates ESD events, right? And so we see it as a feature that we're really measuring charge and not necessarily the voltage. And ultimately, a measure of 0 volts on our device means that there's no charge on the body, right? So now you're safe from ESD events. And it kind of gives that feature that John mentioned, where you walk by an insulator that has charge on it in a facility. The static band will actually pick that up, and I think we've identified concerns that way with our product.
Excellent. And this next slide is showing a graph with a few variables on it.
This is an interesting data set that I collected for just kind of a simple use case of the product. So in our facility, we have an overhead ionizer, and I just did 3 runs, connected a laptop with Chrome browser to the static band to collect this data. It took about half an hour. And I did 3 runs where I stood up and then sat down in a non-ESD compliant chair under 3 conditions. So one was with no ionizer running. The second one, that's the blue curve. The second one is the yellow curve with an ionizer that's pointed straight down at the work surface. And it's a dissipative work surface. And it kind of, it brought reduced my body voltage a little bit, but not sufficiently to be really ESD compliant. And then in the third curve, I actually pointed the overhead ionizer at about 45 degrees so that it was blowing the ionized air straight at my body. And you can see that's the red curve, where within a couple seconds, it actually brought my body voltage back down to 0 volts. So that's just a super quick insight into what does an ionizer in your environment actually do for you to reduce ESD concerns that I think often isn't kind of known by people who use this type of equipment.
Yeah, very interesting. Let's talk about your user interface. How configurable is it, and what parameters can be configured by the user for this type of product?
So we have 3 pieces of software that talk to the device, and that's the mobile phone app, the browser app, which you can just run from any computer that's got a Bluetooth transceiver in it, which is pretty much all of them these days. And then we have the web-based dashboard app. And you can generally, from any app, you can set the alarm levels, so the voltage level at which an alarm will go off. And you can set the threshold level of an ESD event. So you might say, I really don't care about ESD discharges of less than 100 volts because I know that I'm going to damage my device, so I don't want to hear any alarms going off at that stage. You can also have different levels of alarms. So, for example, the dashboard is kind of designed to be a manager view of what's going on. And the manager may want different information than the user. The user may need to get a lot of alarms, but the manager only wants to get alarms at a different level or at different times or with different criteria. So that can be set from the dashboard. At the same time, the manager may want to lock the devices so that folks on the factory floor can't change their settings because it can become critical to not have the alarms disabled, for example. So that there's that ability as well. We've tried to build as a UI that thinks in terms of user stories, if you like. What does a manager actually want to do with this thing? What does a single user want to do with this thing? And give them those controls. Did I forget?
Yeah, no, that's absolutely.
Technologies, all the technologies behind electronics and components, they're often considered a moving target. I like to say our industry changes at the speed of electrons. As such, specifications can change rapidly. In your view, how has the evolution of electronics affected the tolerance for ESD?
It's really interesting because, since the 1980s, you mentioned when CMOS circuitry came out and it was very easy to blow, they've gotten better and better at building ESD into the silicon, ESD mitigation into the silicon to prevent damage. But at the same time, that circuitry, which is usually clamping diodes and capacitors, loads data transmission lines and slows them down. So you have this trade-off that you can either have good mitigation on the chips or you can have high-speed chips, but you can't have both. And it's kind of interesting because it makes for a very rich sort of environment. And then you have a third situation, which is that people like the satellite manufacturers are often using custom chips. So, for example, images that are, where a single imager can cost $1 million. And those don't always have good ESD protection because they aren't commercial circuits. They're custom prototype circuits. Right. And so you have this paradox that sometimes the most consequential circuits have the least ESD protection. So it is a very interesting industry. And all I can say is, anything from 100 volts to 2,000 volts can be people's level of concern, and consequence ranges from more or less no real consequence to a failed satellite. So it's very interesting from that point of view.
And there's an application for kind of hazardous environments as well, right? You're dealing with ignition energies required to ignite kind of flammables and explosives. So much higher kind of voltages than what would damage electronics. But this is kind of a burgeoning market for us where, now you have protection for people who are in large facilities that have kind of explosives. They can also now be ensured that their voltage stays below a desired threshold as intended to stay safe.
I assume since one of the hallmarks of this device is it's wireless, so therefore it must have a battery. Wouldn't make sense to be wireless sensing and you have to plug yourself in the whole time. What is the in-use lifetime of a charge on that device?
We often get asked, so does this take a 9-volt battery or a AA battery, which kind of gives you the state of...
Or a lithium-ion, like an iPhone or something?
No, we built this like a modern-day consumer electronics product that has a lithium polymer battery, charges with USB-C, and the runtime is actually about 20 hours, so you can get several shifts out of a single charge, and it charges up in just 1 hour. So
you're not following the Apple model where it has a lithium battery, but you need a $100 specialized proprietary charger.
No proprietary cables here. And that's what, honestly, in this industry, the interfaces for data transfer are kind of D-bus connectors and stuff that predate, my experience. But this is absolutely made to be easy to use and easy to collect data with.
Well, I'm happy to hear it's USB-C. At least that's the current trend right now. Even Apple, with their 15 models, finally bowed to the USB-C pressure. They were the last people standing. How much training is required to use this product and get it up to its minimum and maximum capabilities?
Very, very minimal. I mean, yeah, anybody can strap this device onto your arm, open up the app, and see their body voltage, right? I mean, that, like I said, you don't even need to read a manual to really get value out of this. And yeah, we made it so that it could be widely adopted, not only by ESD professionals, but anybody who's kind of working around electronics and concerned with it. For the kind of the dashboard and hub backend, that requires a couple hours in installation and kind of collaboration with an IT department. We have built it in a way that it can live entirely within the corporate firewall over an organization. So, data can kind of go to a cloud infrastructure where you can log in from a browser anywhere in the world and see that current ESD situation in a facility. But we also have a version where the server is built on a single board computer and the repeaters kind of all talk over Wi-Fi, but it lives kind of within that local network in a facility.
Using a Raspberry Pi or something different?
You got it.
Yeah, it's a great tool for kind of industrial monitoring and kind of this modern IoT installations. So.
Yeah, we were looking at Raspberry Pi for a project, and the pricing, the specifications, the capabilities were all super attractive. The only problem was we were doing this about a year ago and just couldn't get any. They got caught up in the whole supply chain thing that everyone else did, and sometimes you have to build what you can buy, not necessarily what you want to buy. But hopefully those days are behind us now. I noticed that
you got pretty lucky. We went. Sorry to interrupt. We went to market. If we'd gone to market probably a year later, we would have had some serious issues with components in our device, and we tried to stockpile a few of them, but kind of got lucky that things came back in stock when it was time to launch.
Yeah, you did what we did. We went from purchasing just in time to just in case, and I think companies like yours and mine and all the others that purchased based on opportunity to purchase, we all became part of the supply chain problem because we're all hoarders now, right? You could build a reality television show around our warehouse, where we have our stores. It's crazy, but all of a sudden, if you can buy a year's worth, just buy it. We just basically transferred money from our bank account to our shelves, right? And it's still spendable, and we can't pay our rent with it, but we can certainly use it. Am I right in saying that you sell your products from your website? You sell online?
Yeah, we actually have three channels. So you can buy directly off our website, but we also distribute through some major online retailers like DigiKey, because there are a lot of companies that simply, they want that sense of confidence that comes with having a verified vendor. And then we have specialist ESD distributors carrying our product as well, because these are folks who sell a great deal of ESD material into the industry, and so they're well positioned to.
No, that makes sense, because if you're not on an AVL, there's certain companies that'll never buy from you, and getting on the AVL is, you have a better chance at getting an audience with the Pope, than sometimes getting on certain companies' AVLs. So, we sell our products. We're on a lot of AVLs. We've been around for 32 years. So, we've made our way into most major companies' AVLs, but on the few that we're not, buyers there would rather pay more money, have us sell it to one of their companies that simply resell it back to them.
Absolutely.
At more money, but it's easier to do that than it is to go through the trouble of putting, what they perceive as a new vendor on an AVL. So, yeah, you're doing it wise. You have both channels solved. There are, well, now let me ask you this. Now that you have a sell-ready product that's being sold, so it's past sell-ready, how do you go about updating that product when it needs to be updated? You have a better algorithm, you have better, more features. Is that a cloud download, or how does that work?
Yeah, so every part of the software is updatable, kind of from the mobile apps that automatically update themselves, kind of the computer website, Chrome kind of interface also lives online, so we update that as necessary. And then we actually built kind of the ability to do an over-the-air firmware update on the product itself via mobile phone, via the mobile app, and some other avenues. And so, yeah, it's really built in a modern way that we have full control of kind of improvements as we see them. There's some minor changes that we have coming down the pipe just on ergonomics of the hardware, but other than that, it's performing incredibly well. And changes are kind of minor, if any, just kind of in the process of assembly. We definitely have lots of other applications of this technology, right? Ultimately, we built kind of the world's smallest and most accurate electric field mill, and a wearable armband is one application of that. But we have a whole host of other ways we intend to kind of use that same technology and the data backend to give more visibility into, the voltage on a rolling cart or kind of a workstation mounted devices looking out at the operator. So there's lots of interesting applications of this technology that we have planned for the upcoming months and years.
Well, what I hear from that, what I interpret from that is you're going to be back on the show again to talk about the latest applications. Yeah, you're right. It doesn't need to be on a human. It needs to be on, anything that is mobile that can generate a charge, right? So, yeah, that's interesting. What type of feedback, both positive and suggestive, are you getting from your customers?
So the interesting thing in the feedback that we're getting is that people are just thrilled with the visibility that it gives them into ESD. And we maybe hadn't expected that quite so much because we had gotten used to it because we've been wearing these devices for more than a year. But just the fact that you've heard about ESD, you've been trained about ESD, but you've never actually seen these voltages that occur around you every day. And that has two big issues. And the one is in training, that they're saying it's very useful for training because instead of saying to people, please put on your wrist strap, please put on your heel grounders, there's this invisible, fantasy danger that can kill circuits. You can say, look, you put your heel grounders on and your voltage is 0. You take them off and you go up to 1,000 volts the moment you shuffle your feet. And there's a great quote from one of our users from one of the big aerospace companies. He said, I've been chasing ghosts my whole career, and now I can actually see what I'm doing. And that just, put it better than we could have put it. And it made us really happy because to get that kind of feedback is just priceless.
Yeah, excellent. And we're out of time, so I'm just going to wrap it up with this. Get out your crystal ball, and where do you see the future of ESD monitoring and mitigation going? Obviously, you're bringing in part of the future, but where do you see us, 5 or 10 years from now?
So we see the big breakthrough in making ESD a data-driven science, and particularly for users such as your listeners, where I think there's a strong emphasis on Lean and Six Sigma techniques, where you're looking for those last few decimal places of perfection to improve your yields. And ESD has been this kind of data-free zone for the longest time, and it's responsible for 30% of electronic failures. Everybody, yep, that's the best number there is. So to bring data into that so that you can isolate and track sources of production loss, I think that's going to be huge.
Yeah, absolutely. And the static band, revolutionary as it is, it's kind of only part of the offering that we have planned. So, really looking forward to discussing those upcoming kind of technological breakthroughs with you at a future date.
Yeah, well, I'll be excited to hear about them. I'll check in with you from time to time, and we can get some updates. So, for my audience, if you would like to get a hold of Daan or Jonathan, I will put contact information out on the show notes. If you're listening to this on your favorite podcast app, check out the show notes when you are in a safe place to do so, and you'll see contact information there. And if you're watching this on our Reliability Matters YouTube channel, right down below me, it should say Show More. Click that button, and you'll see contact information for both Daan and Jonathan. So, and the company. So, doctors, Daan Stevenson and Jonathan Tapson, thank you so much for being my guest today, and I wish you nothing but success on your entrepreneurial journey.
Thanks so much for having us, Mike. It was a really great conversation.
Thank you so much. Really appreciate that.
My pleasure. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app. Or if you're watching this on YouTube, be sure and click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And once again, a special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks again for being part of our podcast family. Stay safe, stay healthy, stay happy, and of course, perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.